Welcome to my presentation of the law of cosines. One thing the law of cosines can be used for is to find a side of a triangle given the other two sides and the angle included by them. I'll mark up this triangle with some vertex names and angle names. Also, we've added an altitude. Note that CD is perpendicular to AB. For that reason, we can apply the Pythagorean Theorem to triangle ACD, and we have an expression for AD squared in terms of AC squared against CD squared. Note that CD can be referred to as BC times the sine of theta, considering triangle BCD. Substituting the second equation for CD into the first equation, now we have an expression for AD squared in terms of AC squared and BC squared and beta. Angle addition gives us that AD has a length equal to the length of AB minus the length of BD. Note that BD may be referred to as BZ cosine beta. Substituting BC cosine beta in for BD in the first equation gives us an expression for AD in terms of BC and cosine of beta. Substituting this expression for AD in the third equation at left, we have an equation no longer involving AD. Expanding the left-hand side, moving the second term at the right to the left so that we have a clearly BC squared times cosine squared beta plus sine squared beta, which is just BC squared. So our equation simplifies somewhat, then rewriting it with AC on the left. After all, the law of cosines is normally thought of as a way to find that third side of the triangle. We take the square root of both sides, and we have the law of cosines as it is normally written. Thank you.